Hello, welcome to Business Statistics. In this lecture, I will talk about Chebyshev's theorem. This theorem can be applied to any distribution regardless of shape. So if you see in one of the lectures we discussed about empirical rule. And this rule can only be applied to a normal distribution, which is 68% of the data lies within one standard deviation. So if this is mean mu and this is mu plus 1 sigma and mu minus 1 sigma, so this is 68% of the data. Similarly, if we have mu plus 2 sigma and mu minus 2 sigma, so this entire area is 95%. And then we have mu plus 3 sigma and mu minus 3 sigma, so this entire area would be 99.7%. So this it's Chebyshev's theorem is the same concept. However, it is not necessary for the distribution to be normal. So it can be of any shape. So regardless of shape, it can be of any shape. So what Chebyshev's theorem says is it tries to calculate the proportion of data within k standard deviations. So this is given by the formula percentage or proportion of data is given by the formula 1 minus 1 by k square, where k is greater than 1 and the interval would be, so k standard deviations from the mean, so it will be mu minus k sigma and mu plus k sigma. So what it is saying is, if we consider mu minus k sigma and mu plus k sigma, 1 minus 1 by k square is the percentage of the data that lies within that interval. So this is actually at least one minus 1 by k square is the percentage of the data that will lie between mu minus k sigma and mu plus k sigma interval. So for example, if we have so we can have any curve. So one of the curves might be, suppose if it is right skewed. So this is a right skewed curve. So suppose this is mean mu. So what Chebyshev's theorem is saying is, if this is mu minus k sigma and this is mu plus k sigma, so the amount of data in this, or the percentage or the proportion of the data in this area, would be at least one minus 1 by k square. So we will try to look, put some values for k and look what percentage of data we get. So let's consider k is equal to 2. So the formula is 1 minus 1 by k square, and k should be greater than 1. So k cannot be less than 0, or k cannot be 0, or k cannot be 1. So you cannot put all these values. So when k is equal to 2, our proportion would be 1 minus 1 by 2 square. So this is 1 minus 1 by 4. So this is going to be 0.75 or 75%. So what this is saying is 75% of the data will lie between two standard deviations of the mean. If k is equal to 3, then 1 minus 1 by k square should be equal to 1 minus 1 by 3 square. So that is equal to 1 minus 1 by 9. This is 8 by 9, that is 0.889 or 88.9%. So that means 89, at least 88.9% of the data will lie between 3 standard deviations of the mean. So let's consider, let's try to solve a problem in this. So the same example I want to take as that of my previous lectures. If I have a statistics class, and I am measuring the weight of the statistics class, and I got mean of the statistics class as 160, and the standard deviation as 10. These are in pounds, and the distribution is non-normal. So I want to determine the interval within which %80 of the students lie. So that's my question. So because the distribution is non-normal, I need to use Chebyshev's theorem. So in Chebyshev's theorem, the interval is given by mu minus k sigma and mu plus k sigma. So I have a mu value which is 160. I have sigma which is 10. And I need k, so I have to calculate k. So what is my k? So to help us get k, they told 80% of the data should lie within this. So as Chebyshev's formula says, 1 minus 1 by k square is the proportion. So the proportion here is given as 0.8. So 80% means 0.8. So this is this 0.8, and then 1 minus 1 by k square. So now I have to determine our k square from this. So I will do a mathematical operation where 1 minus 0.8 is equal to 1 by k square, and then 0.2 is equal to 1 by k square. So I can write 0.2 square point 2 k square is equal to 1. So k square is equal to 1 divided by 0.2, which is 5. So k is equal to square root of 5. So I will get 2.236. So once I got k, I can substitute k here and here and get the interval. So my interval would be 160 plus K is 2.236, sigma is 10, that's given. So 160, here it's a minus, it's not plus. This is minus and this is plus. 2.236 multiplied by 10. So this is going to give me 137.64 and 182.36. So what this is saying is at least 80% of the data or 80% of the students' weight will lie between 137.64 and 182.36. So that is how we solve Chebyshev's theorem. So one of the important things in this is Chebyshev's theorem is used irrespective of any shape, and these are only approximations, they are not exact values. So this concludes our lecture on Chebyshev's. Thank you.